So again, we're talking about arithmetic sequences today. A sequence is a list of numbers in a particular order. Each number in the sequence is called a term. A1, the little subscript, is the first term. A2 is the second term, A3, A4, right? You get it. An arithmetic sequence is a sequence in which each term after the first is found by adding a constant called the common difference. And we use the letter D for the common difference. So, example 1. Find the next 4 terms of the arithmetic sequence. Okay. We want to figure out what the pattern is, and then continue that pattern for 4 more terms. Okay, so remember, you're not writing down anything for the first one, -8, -6, -4. You're going to write your answer down for 3, 6, 9. And then afterwards, if you want to write the answer for the first one, you can. So what is my pattern here? -8, -6, -4. What am I doing to this sequence? Jonathan? Adding 2. So this sequence is +2, +2, right? That makes a common difference 2. So what will the next term be? What's the next one in the pattern? -2. The next one is what? 0. The next one is? And the next one is 4. So that's the next 4 terms. Go ahead and do the same thing for the pattern 3, 6, 9. What do we get? 12, 15, 18, 21, right? What is the common difference there? 3. Okay, so the common difference is what am I adding to my sequence every time? All right, next. Find A sub 10 for, oh wait, it didn't transfer well. Sometimes when I transfer a Word document to my Explain Everything, it moves the numbers around. So it printed fine on yours. 7, 16, 25. So find A10 means find the 10th term. -17 is my A1. -13 is my A2. -9 is my A3. So I need to continue the pattern until I can find the 10th term. What is my pattern here? +4, right? My D is 4. I'm adding 4 to every number. So we're going to add 4 to -9 and we get -5. That's A4. Add 4 again, I get -1. Add 4 again, I get 3. Add 4 again, what do I get? 7. Add 4, what do I get? Add 4, what do I get? Where am I at? 3, 4, 5, 6, 7, 8, 9. This is A9, so A10 is 19. So we can say A10 equals 19. That's notation. There's a lot of notation in this chapter understanding what that means. So A sub 10 means the 10th term is 19. Can you find A8 for the pattern 7, 16, 25? All right, so what is my pattern? What's my common difference here? Plus 9, right? So if it's getting bigger, we're adding, it's positive 9. If it's getting smaller, we're subtracting, it will be negative. Okay? So if I add 9, there I have 25 as my A3. So what's the next one? 34, 43, 52, 61, 70. That's 4, 5, 6, 7, and 8. So A8 is 70. Questions? Well, there's got to be a better way. If I wanted A25, I don't want to really have to write out 25 terms for my sequence. So we have a formula. The formula for writing the equation, okay, AN represents the nth term, whichever term you want it to be, equals A1, the first term, plus n minus 1 times d. The n is the number of terms you're interested in. If you're writing a rule, then n stays a variable and an stays a variable. If you're asked for the 10th term, then n is 10, and then you can find a 10. Okay. So we're going to write the rule. Okay, so we're going to write the rule for the sequences we just extended in the first example. In order to write the rule, I need to plug in A1 and I need to plug in D to the equation. Those are the only two things I need to write the rule for a sequence. So what is my A1? Negative 8. And what was my common difference, my D? It was 2. Add 2. Okay, so my formula, my rule, is AN equals negative 8 plus n minus 1 times 2. You're going to plug in just your A1 and your D, and then we're going to distribute and simplify. So my rule is AN, negative 8, distribute the 2, 2n minus 2. Wait, this should be a plus sign. And then that is 2n minus 10. That is the rule for the sequence. Can you do that with 3, 6, 9? Write the rule of the sequence 3, 6, 9. Plug in your A1 and your D. All right, so the pattern is 3, 6, 9. What is the A1? A1 is the 3. What is the pattern? What are we adding or subtracting every time? We're adding. It's really about what we're adding every time, so it's a positive 3. Now, if it gets to be decimals or something, you can take the second term and subtract the first term. So 6 minus 3 is 3, right? It's easy to see in some of them, but when it's decimals and fractions, you may have to actually do the subtraction for it. Now, what goes in my formula? Times 3. AN equals 3. A1 plus n minus 1 times D. D is 3. And then I distribute 3n minus 3. Grab that paper. And 3 minus 3 is 0. So AN equals 3 times n. What this means is if I want to know the first term, I plug in 1 and I get 3. Is that correct? But if I wanted the 25th term, I don't have to write it 25 times. I can just do 25 times 3. That tells me the 25th term is what? 75. 75. Okay. Questions? Okay, we're on to the back side. Find the indicated term. I'm going to write my formula back up here at the top. AN, A1 plus n minus 1 times d. It gives me a1, it gives me d, it gives me n. Plug in everything, and it'll tell me a20. So n is 20, so what I'm finding is a20. The 20th term is equal to a1, negative 4, plus n minus 1, what's n? 20 minus 1 times d. What's d? Negative 9. That's negative 4 plus 19 times negative 9. Don't distribute if it's not a variable. Do the subtraction and then do the multiplication. I need a calculator for 19 times 9. And it's a negative, so that's negative 4 minus 171. So that's negative 175. So a20 is negative 175. The 20th term is negative 175. Now use the second example to find the indicated term. A1 is negative 4, D is 5, N is 15. All right, so what term are we looking for? A15. What's A1? Negative 4. So negative 4 plus, what goes in the parentheses? 15 minus 1 times D, which is 5. Negative 4 plus 14 times 5. Negative 4 plus 70, 66. A15 equals 66. Yes? Write the rule for the nth term of the sequence, then graph the first 6 terms of the sequence. It tells us that A13 is 42 and D is 4. Okay. So I know D. When it tells me that A13 is 42, it's telling me that AN is 42 and N will be 13. So I can plug that information in, and what's the one thing I don't know? I know D. A1 is what I don't know. And I need to know A1 and D to write the rule. So first I have to find A1. So we're going to plug it into our formula. A1 plus n minus 1 times D. So AN is going to be 42. A1 is my variable. Plus n is 13. And D is 4. 42 equals A1. Do the parentheses first. You can do the parentheses. 12 times 4. A1 plus 48. Subtract 48. And negative 6 equals A1. Now I can write the rule because I know A1 and I know D. I'm going to leave the 13 and the 42 out when I write my equation. AN is a variable and N is a variable. So it's AN equals negative 6 plus n minus 1 times 4. Now I distribute because I have a variable in the parentheses, so you can't do parentheses first. And AN equals 4n minus 10. Then it says to graph the first 6 terms of the sequence. So my graph will only have positive x values, and I won't be connecting the dots. This is like graphing a linear equation. If I plug in 0, what do I get? -10. So the graph starts at -10. What's my common difference? My slope. Four. D, the common difference will be my slope. So what do? I go up 4 and over 1, right? Or if I plug in 1, I get -6. So the second term is +4. The first term. The second term for 2 is what? Add 4. What do I get? -2? What's the next one? +2. What am I doing? I'm adding 4. I'm adding 4. I'm adding 4. I don't have to plug in 6 numbers. What's the next one? 2 plus 4 is 6. What's the next one? 10. And the next one, 14. That's my 6 terms. I don't connect them because there is no 1.5 term. This is what's called a discrete graph. It's not connected. Okay, so now you're going to try yours. A15 is -35 and D is -3. Find A1 and then write your rule, then draw your graph. Okay, it says A15 equals -35. What is that telling us? That AN equals what? -35, and it tells us N is equal to the little subscript 15. That's the N. Okay, that will give you -35. So then we plug in our equation, our stuff to what we to our equation. AN, -35. Let me write it again. Equals A1. That's what we don't know. Okay. Now you may be given problems where it asks you to write the rule and it gives you A1, but it doesn't give you D. So plug in what you know to the equation and solve for what you don't know. Okay. So A1 plus N, which we said was 15 minus 1 times D, -3. So -35 equals A1 plus 14 times -3. A1 plus, or minus now, minus 42. We'll add 42. And A1 equals 7. So now I write my equation with A1 and D. AN and N are variables. So AN equals 7 plus N minus 1 times -3. 7 plus minus 3n plus 3, -3n plus 10. That's my rule. Questions on any of that part? Then if I'm asked for the graph, starts 0. The 0 term is 10. And what's the pattern? Down 3, right? The pattern is subtracting 3. So if it's 10, the first term is, what's 10 minus 3? 7. So term 1 is 7. What's term 2? Minus 3 is 4. What's term 3? What's term 4? Negative 1 minus 3 is negative 2. The fifth term? Oh, yep, negative 5. And the sixth term, negative 8. Okay. You're just moving down 3 and over 1 until you have all 6 graphed. Okay. Questions on those? So remember, your D is your pattern. To draw your graph, you're going to go down 3 and then over 1. One more term every time. Or it means subtract 3. Now what if all we know is 2 of the terms? Write the rule for the nth term of the sequence given that A7 is 58 and A11 is 94. Any ideas? Subtract the terms? Okay, so I asked for ideas. Someone said, let's subtract 94 and 58. 94 minus 58 is 36. And then if we subtract 11 and 7, 11 minus 7 is 4. And then what should I do with those two numbers? Divide them, and I get 9. What does that give me? Gives me D. So D equals 9. D is basically slope. So you can do this is basically your slope formula, y2 minus y1, x2 minus x1. So then we're going to plug in 58 equals A1 plus 7 minus 1 times 9. 58 equals A1 plus 6 times 9. 6 times 9 is 54. So 51 equals A1 plus 54. So A1 equals 4. And then we can plug that in. 4 plus n minus 1 times 9. 9n minus 9, which is 9n minus 5. All right, let's do this last problem. So to find D, we can find the slope basically. 96 minus 41, and then 10 minus 5. So that is 55 divided by 5 equals 11. And now that is D. So I need to find A1. 41 will be my AN in this case. A1 plus n is 5. That's this 5 minus 1 times 11. 41 equals A1 plus 4 times 11. 41 equals A1 plus 44. Subtract 44, and negative 3 equals A1. So then AN equals negative 3 plus n minus 1 times 11. Negative 3 plus 11, n minus 11. AN equals 11n minus 14. Okay, now there's another way to do this using systems of equations, and I'd like to show that. If you're Mrs. Whipp's class, this is how she's definitely going to want you to do it. So we're going to plug in the n and the 58 in this problem. So 58 equals A1 plus 7 minus 1 times D. Right, so we plug in 7 for n and 58 for your AN. And then 94 equals A1 plus 11 minus 1 times D. We'll simplify what's inside the parentheses. 58 equals A1 plus 6D, and 94 equals A1 plus 10D. And then we will multiply one of the problems by a negative, one of the equations by -1, and I'll eliminate A1. This is elimination method. We did this at the beginning of the school year. -A1 minus 6D. And we end up with 36 equals 4D. And therefore D equals 9. Then you're back up where we started. 58 equals A1 plus, I'll just use 6 times 9 here. I'm just plugging this in here. And then 58. Then I get 58 equals A1 plus 54. Subtract 54. And 4 equals A1. Plugging it back in. 4 plus n minus 1 times 9. 9n minus 9. an equals 9n minus 5. Same problem. You can pause the video and do the other one the same way. I'm going to show it to you. So pause it, try it on your own. Now let's see if you get the same thing I did. If I go this way, I'm going to go 41. Okay, that's my an, equals A1 plus 5 minus 1, n minus 1, times d. I don't know that yet. Let's pretend we didn't figure that out a different way. And then 96 equals A1 plus 10 minus 1 times d. Elimination method. I have a coefficient of 1 on my A1, so all I have to do is multiply by a negative. Negative 41 equals negative A1 plus 4d. I need to rewrite this. 96 equals A1 plus 9d. Wait, this is a minus, because I multiplied everything by a negative. All right, that's 4d, and this is 9d. So I get 55 equals 5d, and d equals 11. Okay. So this is just another way to solve the same thing. I'll show you that I can use the 96 and the 11, or 10. So 96 equals A1 plus 10 minus 1 times 11. 96 equals A1 plus 9 times 11. 96 equals A1 plus 99. And negative 3 equals A1. So an is negative 3 plus n minus 1 times 11. Same thing we got, a different way to solve it. 11n minus 11, 11n minus 14 equals an. Okay.